Well, so this is the third video of this session, how to build an automobile security system using GSM and Arduino. So nice. In our previous videos, we have seen how to make the proper wiring and how to fix the network registration problem faced by the SIM-800l module. So we will learn to send an SMS, receive an SMS, make a call or to receive a call using an Arduino and the SIM-800l GSM module. So nice. So if you haven't seen my earlier videos, you can see them, or I have also included a schematic diagram in this video. Okay, fine. So this is the cable which will make the connection between your Arduino Nano and your PC, and we are powering our GSM module by an external source, LiPo battery. But see, here is a common ground connection to avoid any risks. Okay, so nice. So let's power it on. Nice. So it is powered on. I have made to shorten the time. I have written all the codes. Now I will go through their lines and explain each and every line in detail. Still, if you have any problems, feel free to make a question in the comment section, or you can inbox me at the provided email ID. So let's code. Okay, so this is the first code. I'll upload all of my codes and provide a link in my description section. You can download them and feel free to use them if you want. Okay, so this is my first code. I've named it test everything. So the first line of the code is hash include software serial.h. Well, the software serial is a library used in Arduino. So let me explain in brief. Devices like GPS modules or GSM modules or 8C05 Bluetooth modules or XP modules, well, the baud rates or the working or the operations of these modules may be different than that of our Arduino. So to create a connection between them, what is the full form of USB? It stands for Universal Serial Bus. So serial is an order in electronics in which the data, the elementary data 1 0, it is passed one after another in a serial order, not in a parallel order. So serial transmission always includes a channel, a receiver on one side and a transmitter on the other. So there should be two ports for the receiver and transmitter. We generally term them RX and TX. So nice. So here we will create a serial connection with another device except our PC. And what is that device? Our GSM module. So this is a GSM module. You see here is the RX and here is the TX. Well, so whenever there is an RX and TX, this suggests that there is a serial communication between this device and your microcontroller. So the software serial.h library is used to initialize any two ports for a serial transmission with any other device like GSM module or GPS module, etc. So the second line of the code create software serial object to communicate with SIM-800l. So this line, after the implementation of this line of code, the thing that happens is pin number 8, it gets transformed to the RX pin that should connect with the TX pin of the GSM module. Okay, so see, when one side is transmitting some information, the other side should receive it. So the RX of our microcontroller, it's always connected with the TX of the external module being used and vice versa. So in our Arduino Nano, the 8 pin, it's initialized as our receiver RX, and the 7 pin, it's initialized as our TX or transmitter for creating a serial communication between the GSM module and our Arduino. Okay, so see, inside void loop we have written nothing but update serial. So we will discuss about this update serial function later. So now just first see that whatever in case of Arduino, whatever we write, whatever the statements are, if they are included inside this void loop, just like the infinite while loop, they run on continuously, they don't stop. But if it is written inside the setup method, the thing that happens is it just occurs for one time and never again. So suppose say we have written a code to send an SMS or to make a call. So if it is in void loop, then the process will be running continuously until and unless it is terminated by powering off or any external agent. But if in case we include it inside our setup, the thing will occur for just once. So for testing purpose, we will write this code inside our void setup. So here we will be using a few AT commands. So what are AT commands? The term AT commands term for, see here in the command line I've written, once the handshake test is successful, it will back to OK. So we will see it later. What is AT? The AT stands for attention command. So devices like GSM module, GPS module, etc., whatever, Bluetooth module, whatever, or it is an XB, whatever it is. So this type of devices create a connection, create a serial connection with your microcontroller, and to some extent those devices are programmable. They are programmable by dint of such AT commands which are listed in their data sheets. So generally for such devices, if we send AT, if it receives OK, this means that a connection is created perfectly between them and it's running all right. So here we have used 3 more statements, the AT plus CSQ and the AT plus CCID and the AT plus CREG. So what does it stand for? So the first line is obviously AT. If it returns back OK, then it suggests that all the connections are perfect, nothing is working wrong. So the second line, AT plus CSQ, it measures the signal quality test and the value lies from 0 to 31. So 31 is the best. Generally it lies between the range of 22 to 27, I guess. Okay, then the ATCCID, it reads the SIM information to confirm whether the SIM is plugged. So say you have unplugged the SIM or there is any loose connection, you haven't inserted the SIM properly inside your module and you are just worrying that why is your project not working. So in that case you can check by typing AT plus CCID and then pressing enter in the serial monitor of your Arduino, and that will confirm you whether the SIM is plugged or not. The last line is AT plus, the last statement is AT plus CREG. So from its name it suggests that it checks whether the module is registered to the network or not. Definitely if your module isn't registered to the network, the LED will not blink properly. Now it is blinking once in 3 seconds, but at that time it will blink fast or it will restart after 6 or 7 seconds of continuous blinking. So inside the void loop we have done nothing but update serial. So how the name suggests, the update serial name suggests that whatever inside whatever is going on between the Arduino and the GSM module, the transmission of informations, the receiving and transmission of informations, whatever is going on, whatever is being shown in the serial monitor, inside void loop we have included a method to update them. So what's inside the void update serial? So there is a delay of 500 milliseconds. Well, it is given as a relaxation time so that the microcontroller may work properly after the GSM module carry on its instructions one after another. I mean, if there is no delay and if there is a continuous transmission of instructions from the microcontroller to the GSM module, it may malfunction, it may hang up. So to avoid such risks, we have included a delay command here. So in future we may customize this to some extent and remove, and we may even program without using any delay commands because delays are not at all good for microcontroller programmers, since they may hang up any analog or continuous PWM process included in your project. Okay, so now for just the sake of simplicity we are using delay command over here. So the first line is while serial.available, which means if data is available in the serial ports of your microcontroller, which means 8 and 7, which means if any data is available in the serial, I mean whenever you are typing something and sending it from the serial monitor, I mean here is our serial monitor. See, so here, okay, so I was running another code, so it's shown the output of that code. Fine, that's not the issue. But here we need to write the AT commands that we need to send to the Arduino, and by just pressing enter or clicking on the send button, they send that specific code, that 80 command to that. So what is the way of transmission? We are transmitting a string, some bits of information from our PC to the Arduino, and the Arduino is thus forwarding the command from it to the GSM module. Okay, so fine. So this is our serial monitor GSM. So we have created our own serial ports, which we named my serial. We have created our own serial transmission object by using the software serial library, and that is used for making a connection between the GSM module and the Arduino. Okay, so nice. So inside the update serial method, see while serial.available, I mean when you are sending some command from your PC, which means there is some data available in the serial port, then my serial.write, serial.read, your data is being read by the command serial.read. It returns the object which you sent through your serial monitor. I mean, you type something and press enter, it is available to the serial port of your Arduino Nano. So while serial.available, when something is available in the serial port of your Arduino, it reads it, serial.read, and it writes it back to the my serial, which means it writes it back to the 8th and the 7th port, which is connected to the GSM module. So the command you are typing, you are sending to your Arduino from your PC, it goes to the GSM module. Similarly, just the reverse happens over here. While my serial.available, I mean when you are sending some SMS or making a call, whenever there is some data available in the serial port of your GSM module, my serial.read is being written to serial.write, which means whenever some data is available in the RX and TX port of your GSM module, it reads the data and writes it back to your serial port, and thus you see the data in your serial monitor. So this is such a simple concept. I'm sorry. So let's run the code. Okay, something is going wrong. It should not take this much of time. Okay, so go to tools, port 14. So our circuit is all fine. So now just let's run it. So nice, it's showing done uploading. So let's open our serial monitor. So this is our serial monitor. Okay, so nice. So we'll see something is shown inside our serial monitor. In the first line it is showing initializing, the second line it's showing 80, then okay, then 80 plus CSQ. Okay, follow our codes over here. The first line was serial.println initializing. So whatever if you write this code, whatever you are writing inside this println, this gets printed in your serial monitor. You see the first line is initializing, then the second line my serial.println 80. So this means that you are sending a command 80 to which serial object? To the 8th and the 7th pin, to the serial object which is making connection with the GSM module. You are writing a command on that serial terminals. So what was your command? Your command was 80 which was to test whether everything was okay, and it returned okay, which means everything was okay. Then the second command, it's for checking the signal quality or the signal strength. So it lies in a value within 0 to 31. See, it's a moderate, I am having a moderate signal strength over here, so it's showing 25. Okay, it's fine for making calls or receiving calls or sending SMS, whatever. Now see, the fourth command that was sent to the GSM module was the 80 plus C rec. I have told earlier that it was for checking the registration status, and it returned 0 1, which means it's connected to the network. So nice, this code worked properly. So here are a few codes. So let's try 80 plus COPS, 80 plus COPS, and then press enter. It's shown you an error. So okay, let's try 80I. So the 80I, this shows some basic information about your module, and I don't know why that shown me an error. Let's try it once again. 80 plus COPS. Let's give it a try once again. Okay, so nice. So 80 plus COPS, this give you to some extent some information about your telephone network service provider and all that. And this COPS colon 00 Airtel, this suggests that you are receiving a connection, you are registered to the network, and your network operator is Airtel. And there is another code which has a slight difference. There is another command which is slightly different from this command. The command is 80 plus COPS equals to what? Now I press enter. See, it takes some time. See, but after taking some time, it is returning a list of operators available. So what is the difference? 80 plus COPS, it shows you the operator which is providing you the network with which you are connected, and 80 plus COPS equals to question mark, it returns a list of all the available operators that you may connect with. So we are done with the first code. One more thing is, if in my case, see, I am powering on my GSM module externally with this LiPo battery. So in case in our phones, nowadays in almost in every phones we can see our battery status, and this was an idea from the very primitive time when cell phones came in our hand. So nice. So there is also a clever way to get the battery status, to measure how much of the charge is left in our LiPo battery. The command is 80 plus CBC. It returns you the battery status. See, 80 plus CBC, and then question mark, then press enter. Oops, it's giving me some error. Let's give it a try. Okay, so 80 plus CVC, no question mark, I'm sorry. So 80 plus CVC, it returns that it has 4050 milliampere hour of charge still inside it, and thus it has 81% charge. I don't know what the 0 means, but this means that your LiPo battery still has 81% charge to provide power to your GSM module, and 4050 mAh of battery is still left. So nice. So in this video we have seen how to make a connection. In our previous videos we have already seen that how to make a connection, but in this video, alongside making the connection, we have also came to know about number of 80 commands. So friends, believe me, these commands are going to be very useful if you are going to work with advanced concepts like Wi-Fi or GPS or GSM or whatever. So I think you have enjoyed this video. Please like, share and subscribe this video if you like. In our next video we will see how to send an SMS, how to receive an SMS, how to make a call or how to receive a call. So since this video is becoming a bit long, I am trying to shorten them it would be boring if it is too long, so I am making it in two halves. In our next video I'll surely show you how to send an SMS, receive an SMS, make a call and receive a call using your Arduino and your GSM SIM-800l module, and the circuit is 100% working. Thank you for watching.